So today we're going to be talking all about mathematical modeling and then direct variation. Two pretty straightforward things. Mathematical modeling really only takes place on our calculator. There's not much we actually do on paper for it. Okay? So that's why I asked you to get your calculator, because we're going to actually do the steps today. Okay? All right. Everyone have a calculator? Patrick, Ian, you guys got a calculator?
Yeah, I'm going to get a calculator.
For your row? Look at that. Wow, you're so kind. Okay, so mathematical modeling. All we've got to do is type this table into our calculator, okay? Before we do that, let's make sure we have our calculators cleared, because my Algebra 1 kids were using them last period, and I don't want whatever they did to mess you up. So we clear second plus 712. Okay, so just clear your calculator. All right, now the steps are on here at the bottom, okay? I'm not going to be able to leave them on my screen because I want to zoom in on our table, but they're all right there. So you're going to press your stat button. And then you're going to enter in this table. Now, before you start typing away, look up here. I give you a specific set of instructions down in my directions. It says T equals 0 corresponds to 2000. So instead of in your table typing the number 2000, you're actually going to type a 0. Oh, that was a terrible 0. 0, 2001 will be 1, 2, 3, 4, 5, 6, and 7. Okay, so that's what we put in our X column or our L1 column. And then we're going to type population into the other side. Okay. Yep, so you stat. Just type it in for a second first. Don't actually find your equation. Okay, I'm going to do it too.
Do you have? No, actually, no.
Are you serious for me?
What?
What did you just say?
Well, I'm going to ask a question.
All right.
What are we
What do you guys or opportunities for?
The answer is yes. We all are going to the opportunities fair.
There's really not a reason for
I understand that, but you guys got to go. Just walk around, get some exercise. Go get me all the free pencils. Because I need some more. So go around and get all the free pencils and bring them
I
back.
can't figure out how I like.
Do you get to the table? So it's stat.
Oh,
There you go.
God, pressing the right button.
Stat. There you go. Stat, enter. And that'll give you your table. That's how you're filling it in.
Yeah, it's really cool. It's too exciting. I don't think the schools are out of it.
How do you think you're doing? Are you worried about it?
Not really.
What's up?
Okay. At this point, everyone should at least have it typed in. We there? Anyone need another minute? I know some of us walked in late. Did you type this in your Go get a calculator. You need to practice this one.
I don't know how to do this.
We're going to do something new with it. So I want, not that much new. It's just one new button that we got to press. Okay. All right. So this is typed in. Now I want you to find your equation. So we're down here. You did this already. That was just filling in your table. Now hit stat again. But this time use your arrow to go over one to where it says calc. And we want to hit enter on 4. So you can either hit the number 4 or you can use your arrows to go down to 4. Okay? And it's going to give you like a list of things. You've got to go hit calculate until you see a screen that says y equals ax plus b at the top.
So we click stat again after we have the points there?
Yes, so after you hit the points, you hit stat again. Then go over to calc with your arrow. Okay. And you want to go to 4. Okay. So you see something like this. Okay. And what does it say for our A value? What did you guys get?
2.78.
Yeah, 2.778, something like that. Okay, I'm cutting it off there. I think you have more decimal places. If you did not get this, my guess is you probably typed something wrong into your table. Okay, so detail matters for these guys. So let's just make sure as we type that in, this might be something worthwhile to double check before you do this, like on a test, for example. Okay, so this is what we should get. That's what your calculator screen should say. Okay. We would just rewrite it. My A was this, so I'm going to write 2.778 for where my A goes in my equation. And that will be my y-intercept. Okay, so your calculator's doing all the math. You're just typing in, oh, that should be an X, not an A. Hold on. X. All right, so that's just getting our equation. Any questions on how we find the equation in our calculator? We did this in Algebra 2, okay? All we just did was we found our line of best fit, if you think about scatter plots, okay? Now, these steps right here, guys, these steps you're going to have to remember. Okay, I'm not going to give them to you on the test. Okay, so just know, when in doubt, hit stat. Okay, when in doubt, hit stat. That's what I tell my Algebra 1 people. Now, this question. Okay, so we just did this one. I probably should have written it above here. We just found the equation. That's this. Question 2 is asking, does the model fit the data well? Okay, AKA, is it a good fit? So here's what you're going to do. I want you to go to hit your y equals screen, or your y equals button at the top. And I want you to type this equation in. Okay, so type this equation in now that we found. Okay, you probably typed maybe one of these numbers up top wrong then. That's all that means. Okay? Did you? I rounded my last ones.
2.78 and then plus 2.
Oh.
2.5.
That's just because you rounded. Like I kept going. Not necessarily. I'll tell you on the test which one to round to. Did you type it in your y equals screen? Okay, just leave it like that for a second. Okay, we don't graph it yet. Did you hit your y equals?
Yeah.
Okay, and you typed it in. Okay, now I want you to hit second graph because we want the table. Okay, second graph, we want the table. Okay. Are we all looking at a table now with a bunch of numbers, crazy decimals? Okay, so now on your paper, we're actually going to write something for once. Here we have, we're going to extend our table a little bit. You don't have to write these lines if you don't want. You're probably going to be just as organized without them, okay? But now I want you to write model up top, okay? Model is a fancy word just for our equation, okay? So just look up here for a second because I'm just going to point to things. This column right here is our actual data, okay? This is the actual data that was collected. This is going to be what our model would predict. So when we plug that equation in, if I were to plug a 0 in, what does our table say for 0 in this spot? What does it say? What number does it give us in our table? On your screen. Right. 2 is it? What is it?
282.5.
282.5. All right, it's 282.5. Okay, so in other words, this is my actual data, but using the equation that our calculator just spit out, this is what we would predict. Okay, so not far off, but different numbers. Okay, so let's fill in this table now with what our equation would be predicting. Second, and then graph. So we get our table. And now these are our new prediction numbers. Okay, I'm going to use yours. Second. 22. All right, so I just showed in our table. So again, we just have to know the difference, right? Actual data, what are equations predicting, right? Mathematical model is just a fancy name for an equation, okay? So if you look at my numbers right now, they look pretty good. Like it looks like it's pretty strong, right? In terms of how good our prediction would be. Most of these numbers are pretty doggone close to what we got for our actual data. They're just decimal places off, okay? All right, this is the new step in our calculator. Our calculator is going to show us just how good of a fit it is, okay? So on your calculator now, let me see. I'm going to write this. I'm going to write it here. Find an empty spot on here, okay? This is how we determine if something's a good fit. This is the new stuff. Now, we just cleared our calculator. So your calculator right now is set at its like default settings. In order for our calculator to show us how strong of a connection is, we have to change its settings. So you're going to hit the mode button. The mode button is right next to the blue one up top. And then I want you to go, you got to go pretty far down until you see written in blue, it says Stat Diagnostics, and you got to turn it on. Okay? Okay? Right now it's on off, you got to turn it on. Okay? So your calculator will always default to turning those off. Okay? You're going to have to be the ones to turn it on. All right, did we all find that? We all turned it on? Now I want you to go back to our screen that showed us our equation. So we hit Stat, over to Calc, down to 4. Okay, go back to that screen. And you're going to see some new numbers now show up that we didn't see before. Okay? If you need to get out of settings, hit second mode and it'll get you out. After you go down to 4,
Okay.
LinReg. Yep.
And then calculate.
Yep, and then hit calculate. Yes. And now we see an R squared and an R appear at the bottom, right?
How do you expect us to memorize all these steps?
Okay, it'll be a lot easier when we do the next one. Because right now you're learning it for the first time. So you hit Stat again. You go over to Calc. Down to 4. Okay? The R. So ignore the R squared. Just the R says 0.99, right? Okay. Oh. 0.99. This tells us, this is a decimal, but it's really giving us a percentage. What would this be as a percentage? 99%. What this tells me, this is what we call our correlation coefficient. So I'm going to write that word. You don't necessarily have to remember it, but correlation coefficient. Your correlation coefficient tells me how accurate my model is. So for example, my model is accurate 99% of the time. So that's pretty good, right? 100% being perfect. If we have a correlation coefficient that's in the 90s, we say it's a good fit or a strong fit. Okay? Good fit. So that number right there, we're not just guessing, we're not just saying, oh, it's good, that seems right. We got to find that correlation coefficient.
Mama did me right.
Okay? All right. So now, let's just try, because again, this is a lot all at once. We're going to do it straight through how you would do it on a test now. And hopefully it'll click a little more. So right now, clear your calculator. 2nd plus 712, because we're going to use a new table of values. Okay, so clear your calculator. 2nd plus 712. And now flip your paper over. And we've got a new table. Okay, now before you start typing away, set your calculator Stat Diagnostic on. Just set it now. Put it on. Okay. Mode. Yep. Mode. Well, we're going to Stat Diagnostic in mode. Okay. So the first thing you do when you get to this problem, and I'm asking you for a mathematical model, just turn it on. Turn stat diagnostic on. Okay? Then, go all the way down to the bottom, move it over, and then you'll hit enter. Okay? Okay, so now we've got ourselves a new table. This is super important up here. Let t equal 0 represent 2,000, which means I'm going to type in a 0 here. 0, 1, 2, 3, 4, 5, 6, 7. So now get yourself to that table, right, that we got to type in. Now, what's our favorite button? Stat. When in dat, hit stat. When in dat. Okay? So we hit stat. That's what we type our numbers in. So go ahead, fill in your table. Come on.
How do I get to the original table?
So it's stat. Enter. Okay. Once you filled in your table, you're ready to now find your equation. All right. Okay, so if you typed it in right, this should be our equation. And then if you turned on your stat diagnostic, our R value should already be there.
I ran up to 1.
Okay. Yeah, I'll probably have you guys round to 2 decimal places. So because it's all 0, yeah. Now, what is my R value on my calculator? What does it say? 0.99 again. So that tells me it's 99% correct. So it's a good fit.
It's not 100, so it's not.
It's not perfect, right?
Will we ever find one like that?
Nope. Well, the only time we'd ever find it is if this is a totally linear table.
Okay.
So it's the same slope every single time. But we're always going to be looking at scatter plots, so that'll never happen.
Gotcha.
All right. Any questions on mathematical models?
No.
Okay. All right. So now let's talk about direct variation. Pretty easy. Okay. It should come pretty quick. You did learn this in Algebra 2. That's why we're going to go kind of fast through it. A couple different statements that you're going to see in word problems. Okay. You might see the wording, y varies directly as the nth power of x. Okay, so direct variation all comes from word problems. So we're just going to write down some key phrases that should tip you off that we're doing direct variation. Y is directly proportional to the nth power of x. We'll talk about that. Nth is just like an exponent, basically. Or you literally might see y equals k, x to the n. There's your nth power there. For some coefficient. Okay. Does it help you? Is it necessarily? Sure. You also can write constant, okay? K is the coefficient in front of x, but it's also a constant term. It's never going to be a variable, okay? So in this last part, if anything, write this down. Coefficient or the constant of variation. Okay? Now, in Algebra 2, we only ever saw x's in direct variation that had an exponent of 1. So in Algebra 2, you only ever saw this form. But today we're going to see some that actually have some exponents going on. Okay, not many of them. I think we actually just have one today, but... All right, the key here with direct variation is that we have no y-intercept. Okay, no y-intercept for these. It's just, or I should say a y-intercept of 0, actually. That's probably way better. It's not no intercept. We have a y-intercept of 0. Okay, but you won't see one written. All right. So let's just do one. I'm sure it'll come back to you pretty quick as we do this first problem. It says, in Pennsylvania, the state income tax is directly proportional to gross income. So there's that directly proportional that tips me off. Okay, there's that wording. You are working in Pennsylvania and your state income tax deduction is $46.05 for a gross monthly income of $15,000. Find a mathematical model. Remember, mathematical model is just talking about an equation. It's just a fancy word. So when you see that, don't panic. Just means write an equation that gives the Pennsylvania state income tax in terms of gross income. Okay, the wording is half the time the most difficult part here. But a good rule of thumb is always the first thing that I have listed, state income tax, that's always my y. In math, the word is means equals. Directly proportional is telling me that I'm going to have that k value that we have in direct variation. And then the last thing I have listed is my x. Okay, so the order that the sentence is written is giving you what your equation is going to look like. Okay, the first thing's my y, is means equal. This directly proportional tells me I have the k in there, and then gross income is last. Okay, so you can label it like this. Let's just make sure we also define our variables.
So is this
Okay.
like something to look for the test? Like you see like...
Mm-hmm. If you see anything saying directly proportional, you know this is the kind of problem you're looking at. Okay?
Okay.
Any of those wordings that we wrote down in the last one. Okay? So Y is talking about state income tax. X is talking about gross income. You don't need to define K because K is going to become a number. Okay? Okay, K is our constant. That's the whole goal in these problems. You need to figure out what the constant is or how state income tax is directly proportional to gross income. That's ultimately our goal here. Okay? So, when I give you these problems, I'm almost always going to give you a piece of information. Typically, it comes later. Sometimes it does come in the beginning. Okay, but I'm giving you this piece of information that you are working in Pennsylvania and your state income tax deduction is $46.05 for a gross monthly income of $1,500. Okay, so here's my general form. Okay, in general, my equation is going to look something like this. We just need to eventually get a number there. Okay, so I'm going to plug in the two pieces of information that they give me. It says your state income tax deduction is $46.05. So I'm going to put my $46.05 in for the Y, because that's my state income tax. Okay? So I plug it in for the Y. I bring down my sign, I bring down my K. And then it says I have a gross monthly income of $1,500. So that goes in for X. And now we just solve for K. So I'm going to divide both sides by 1,500. And so let me just see, what do we get? K is going to give me, it's a decimal, 0.0307. Okay? Now, we're not done, because remember, I'm telling you to find a mathematical model. So my final answer for this problem that I box in is not going to be a number. It's going to be an equation. Okay? We go back to our original form, y equals, but now I'm going to write the k value that I just found with my x.
Were you plus 15 or was it just that?
Plus, nope. So this, good question. This line right here that I give you, these numbers, just think of it like a tool. It's a tool I give you to find k, but it's nothing to do with my final answer.
I thought K equals that number, so how does Y also equal that?
Oh, I see what you're doing. This, I just substituted in for k up here.
So you just write the equation
Mhm.
6.05 equals that 0.07.
Right. So I took my general equation. I used that sentence right there to plug in some numbers because I got to find k. I don't know what it is. So these numbers are just a tool to help me find k. But then once I find it, I got to plug it back into my equation. Okay? All right. Any questions on that first one? Finding our equation? All right, let's do another one. Now, number 2 here is what most of your problems are going to look like. Most of your problems are going to have 2 parts like this. The first part being what we just did, finding a model. The second part is going to be you using that model to answer another question, okay? So let's just read through this one. It says the distance of a ball rolls down an inclined plane is directly proportional. Right there, that tells me I'm doing this kind of a problem, directly proportional. I've got to have a k somewhere. To the square of the time it rolls. Okay, so before we even get to the first part, let's just figure out what our variables are going to be. Okay, the first thing the first unit of measurement that's happening here is distance. The distance a ball rolls down an inclined plane. That whole thing is going to be represented by y. Okay, you can just abbreviate y as distance, or distance the ball rolls. Okay, that's all that means. So again, the first thing I tell you in the sentence is my y is equals in math. That directly proportional just tells me I have that k value. And this last one, to the square of the time it rolls. Okay, so the unit of measurement here is the time that it rolls. Okay, so that's going to be my x. But here we also have the square. Okay, so I have y equals kx squared. So now we have to pay attention to that word squared to know that I have an exponent here. It's not just a linear term. Okay. X being, I should define that. X being time. Okay. Any questions on finding this general form? Slightly different. We haven't seen this yet. That was not in Algebra 2. All right, so now we're just going to find our k value. So this last little part here is the tools that it's giving me to find my k. So it says during the first second, the ball rolls 8 feet. Okay? So first second, that's telling you my x value is going to be what? What's my x value? How much time has passed?
8? Wait,
Not 8.
3.
And during the first second, how much time? Yeah, just 1. Okay? So x is going to be a 1. Then our ball rolls 8 feet comes into play. That's my y. Okay, so I put an 8 in for the y. Bring the rest down. Don't forget your little square. It doesn't really impact us here, but I'm going to make sure we have it. And now we solve for k. So this one just becomes a 1. So I would divide both sides by 1. You probably already can see it, but just to show our work. Okay? So we would...
Squared.
Yeah, but 1 squared is 1.
Yeah, but how come it is?
How come it's squared?
Yeah.
Because up here, see what I've squiggled? It says proportional to the square of the time that it rolls.
Okay.
So that line right there. So for example, if this was going to be a 3, what would this say?
Cube.
Yeah, to the cube. Okay? All right. So we found our k value to be 8, but let's go back and we've got to plug it back in to our general form here. So I've got y equals 8x squared. That's my general form. Okay, so that's part A. Write the equation relating the distance. That's this guy. We checked him off. We just did A. Part B is always just going to be using our model now. So it says, how far will the ball roll during the first 3 seconds? Okay, so I'm giving you 3, and that's talking about what variable again? X. Yeah, so let's plug a 3 in for X. So I've got y equals 8, plug a 3 in squared. So it becomes a 9, and we get 72. Okay, so for part B, we would say during the first 3 seconds, the ball rolls 72, and what are we measuring this in? Feet. We get that at the very end up here. Oop, the ball rolls 8 feet. Okay? 72 feet. All right. Any questions on that? Yeah. So, here's what we're going to do, because after lunch, you guys are just going to go to the Opportunities Fair. I am going to be there, so I'll look for you. So don't think you're just going to sit in the cafeteria, okay? You do have to go. But we do have to do this before you guys leave. So here's the deal. I'm going to cross this off. You don't actually have to plot your actual data, okay? So I'm on the next page, page 20. So listen, I'm going to show you what we're doing in a second, but for right now, just cross off the plotting the data. All I want you to do instead is do that extension of the table like we did on the first one in our notes, okay, where we listed out the new ones. So instead of actually plotting points and graphing it, just list out the new ones, okay? So your assignment is listed pages 20 to 23. However, what you'll notice is 21 is like one question. 22 is actually one big example. There's not actually a problem on there. Okay? So you're going to do, it's 2 different direct variation problems on page 23. And then you're going to do this one problem about mathematical model. Okay? It's just spread out a bunch of pages. Okay? You can show it to me at the end of class. If you don't show it to me at the end of class, then there is an upload option on Schoology. Okay? Yeah. Yes, yes.